Here's my Lab 1 makeup. Here's my doctor's note for being excused for Lab 1. Here we have the first part of the pre-lab for Lab 1, the 2x1 multiplexer truth table. For problem 2 of the pre-lab, I have my end gate and circuit lab. So as you see, they are both on 5 volts right now, or digital 1, and you get an output of close to 5 volts. If I were to change one of them to 0, you would see that it would get closer to 0. And if I change the other one to 0 and this one to keep the other one on 5, you will also see it is close to 0. And when they are both on 0, you have 0. For the third part of my pre-lab, here is my OR gate and circuit lab. So we see right here that both inputs are at 5 volts, which is giving us a close to 5 volts reading on the voltmeter. If I change one of them to 0 and leave one at 5, you will see that it still stays near 5 volts. If I change both to 0, you will see that it will get closer to 0 volts. And if I change input A to 5 and leave input B at 0, you will see it will go back to 5 volts. This is the OR gate. For the next part of the pre-lab, here's my NOT gate and circuit lab. So you see that when V in is at 0 volts, we have a V out of 5, which is resemblant of the NOT gate. If I were to change V in to 5 volts, we will get a closer to 0 V out output. This is my 2x1 multiplexer and circuit lab. Right now, all my inputs are on, which is giving the voltmeter a reading of 5 volts. If I were to change VB to 0 and just leave the other two on, the voltmeter reading would be 0. If I were to turn the V selector off and the VB off and just leave VA on, the voltmeter reading will be 5 volts. And just another example, if I have VB on and VA on and not the selector on, we will have a 5 volt reading for the voltmeter. Here is my Tinkercad portion of my lab. I have here my circuit with my 3 chips, my resistor and my LED, and then my 3 input wires, A, B, and the selector input indicated from the yellow, blue, and green wires. Right now, all 3 are on, which is powering the LED on. If I were to get rid of input A, turn that off, and leave the other 2 on, this will also power the LED. If I were to get rid of input B and just leave the selector on, and A is also off, the LED will not light. If I were to turn A and B on and turn the selector off, this should power the LED on. And all this relates to the truth table. Here is the last part of my pre-lab, the 4x1 multiplexer example, which is a combination of several 2x1 Here's my lab demonstration for the 2x1 multiplexer manually. Right now you can see that I have my 3 inputs, A, B, and the selector input powered on, which is powering on my LED. When I just take away input A and turn that to ground, give it no volts, and leave the other 2 on, the LED still works. If I were to power off B and A is off and just leave the selector on, the LED will not work. If I were to turn on A, leave B off, and have the selector on, the LED continues to not work. If I turn the selector off, have A and B both on, the LED will turn on. This is a demonstration of the 2x1 multiplexer manual. Here is my 2x1 multiplexer Arduino demonstration. We put input A and input B into pins 8 and 4 for this problem. And here is my Arduino code that will allow my circuit LED to blink at 2 different frequencies when I adjust the selector pin. So here you can see that the selector pin is powered on, which is allowing the LED to blink at a frequency of 0.5 hertz. And when I move my selector to the ground and giving it 0 volts, it blinks at a much higher frequency of 10 hertz.